Our campfire is arranged in the unit circle. As you can see, we have twigs extending from the center of the campfire out towards the circumference of the campfire. Now, each twig forms a separate angle. The angles are in degrees: 30 degrees, 45 degrees, 60 degrees, 90 degrees, etc. However, there are also arcs formed from these twig arrangements. There is pi over 6, pi over 4, pi over 3, pi over 2, etc. Each one of these arcs or angles has its own reference angle. A reference angle is the angle from the terminal side to the closest horizontal axis. In the case of pi over 6 or 30 degrees, it is also pi over 6. Here's my lovely sister Sokatoa to explain the meaning of her name.
Hello everyone, my name is Sokatoa, and my name stands for sine, cosine, and tangent values of the unit circle. So sine is opposite over hypotenuse, as you can see here. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, as you can see here, the hypotenuse is always the radius of the unit circle, and it's always 1. Brother has explained before, you would refer to its reference angles to determine its trig values in the unit circle. But here we're only explaining quadrant 1, and naturally, in quadrant 1, the reference angles are just the angles or arcs themselves. So here I have a little neat trick to explain to you, or help you memorize these different the basic values. So as you can see, this is the angle of 60 degrees, or pi over 3 radians. And the sine value is the y coordinate, and the cosine value is the x value of the coordinate, and the tangent value is the y over x value of the coordinate. So as you can see here, if your reference angle is 60 degrees, or pi over 3 radians, its cosine value would be root 1 over 2, and its sine value would be root 3 over 2. And naturally, when you have the sine value over the cosine value, you get the tangent value of root 3. So there is a neat little trick to remember these values. So you would write the fraction bar over 2 for every single coordinate value. And then you would write, starting from here, root 1, root 2, root 3, and then root 1, root 2, root 3.
There's also my side of the story. My name is Choshikao, and my name stands for cosecant, secant, and cotangent. Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Choshikao is the reciprocal of all of Sokatoa's values. As you can see here, my values would be 2 over root 1 instead of root 1 over 2, and 2 over root 3 instead of root 3 over 2. I am direct reciprocal of Sokatoa.
The main thing you need to know for inverses is where they exist and their values. So sine is quadrants 1 and 4 only, cosine quadrants 1 and 2 only, and tangents quadrants 1 and 4 only. When I say only, I mean that the other quadrants do not exist at all. You can't go through them or around them to get to any other values. So, to do these problems, you have to just think backwards. Arc sine of a half. So you think, what angle has a sine of a half? And it's 30 degrees. So your answer is 30 degrees. Next, you have arctangent of root 3. So tangent is root 3 at 60 degrees, so that's your answer. Next, you have arctangent of negative root 3. So the way you do this is you figure out where is tangent negative, and it's negative here and here, but this quadrant doesn't exist. So you have to get to where this is negative root 3, which is at 300 degrees, so you go backwards 60 degrees to get to that line where the tangent is negative root 3, and then your answer is negative 60 degrees. Next we have arcsine of negative half. So sine, of course, is 1/2 at, sine is negative in quadrants 3 and 4, but for sine, quadrant 3 doesn't exist, so you have to go backwards 30 degrees to get to a value that has a sine of negative 1/2, and your answer is negative 30 degrees.
Okay, so I'm going to teach you guys how to graph sinusoidal transformations with the sine function. So the first thing you do is you use this formula, which is like the basis for all of them. So it's y equals a sine b x minus c plus d. A controls the transformation, the amplitude, which is the distance between the sinusoidal axis and the maximum. B controls the length of the period. C, which is how long the graph is. C controls phase shift, which is basically where the graph starts. And D controls where the sinusoidal axis is. So the first thing I'm going to do is fill in values for these 4 numbers, for these 4 letters. So the first thing I'm going to pick for A, 2, B, also 2, C, pi, and d, let's do 3. So the first thing I do is I put the sinusoidal value into the graph, the sinusoidal axis, so 3, and then the amplitude, so up 2 from 3 is 5, and then down 2 is 1. And then I do, let me draw this, y equals 3, or SA equals 3. Now I'm going to fill in the phase shift, so it starts at pi, and now I'm going to do the length of the period. So there's like a formula that you use, that's 2 pi over b gives you the period, and it could also be reversed, so you could do 2 pi over the period also gives you b, but since we have b and we're looking for the period, we're going to use this formula. So that's basically 2 pi over 2 equals p, so the 2's cancel out, so pi equals p. So then basically to find the quarters so that we can plug it in, you do the period over 4, so in this case it's pi over 4, and these are quarters. And actually, to make this easier on myself, I'm going to change c to pi over 4, sorry. Okay, so now I basically just fill it in, so I add pi over 4, so 2 pi over 4 basically, so that's basically just pi over 2, and then 3 pi over 4, 4 pi over 4, which is just pi, and 5 pi over 4. No, you stop when you get to where the period is, so in this case, pi. So the first thing I do is I start plotting out my points. So since it's a sine, I'm going to start on the sinusoidal axis. This is going to be pi over 4, 3. Then I go up, so pi over 2, 5. Then back to the sinusoidal, 3 pi over 4, 3. And then back down, pi, 1. So now I fill this in. The line, kind of messy line.